All right. Uh, well, welcome everyone who is here. If you, I'm sorry about the confusion. Apparently, it was posted in Simplicity for 5 p.m., even though I scheduled it for 6. I was not aware of that, so apologies for those who show up earlier and the session was not there. That being said, this is going to be posted. I'm going to make sure it's posted to the EPICS YouTube channel so you can watch it later. Today's session is going to be, I'm going to be talking to you about sensors and actuators on Arduino. So I'm hoping that by this stage in the semester, if any project you're working on, you have been using Arduinos. I will guess that you have encountered the situation where you needed to work with sensors and actuators up to some degree. So this may be familiar. This might be like a review of things we have done, but I'm gonna try to break it down a little more. So. Um, First, I'm going to start talking about input outputs of different Arduinos. Some of their um, um, communication protocols that you need to keep in mind as you work with different sensors. Mention a couple sensors and actuators, and lastly, some consideration as you start designing your project with Arduino. And lastly, I'm going to have some examples for you to work on a few some of the concepts that I'm going to be talking about. So first, as you might be familiar with, this is the Arduino Uno. So this is the pin out of all the inputs and outputs, as you can see. A few remarks that I want to mention. This one in particular has 14 digital input outputs, 6 analog inputs. Of all the digital input outputs, 6 of them are PWMs or pulse wide modulated output, which for some applications you might be using those. And another things I wanted to point out, the output of each pin is maximum 40 milliamps. Hopefully you're not supposed to get closer to the maximum. That's something you have to keep in mind as you design and you connect things to the Arduino. A few other things I want to mention. We have on the left side, we have some voltage output. So we have the 5 volts and the 3.3 volts. Depending whether you're powering the Arduino from the USB port or the DC power jack, the 5 volt is going to have a limitation based on that. So if you're using your computer, it's most likely that the maximum output is going to be 500 milliamps. And the 3.3 volts output, or 3.3 volts pin, more up to say, is limited to, I believe, 200 milliamps. So these are things I'm mentioning because as you start working and connecting things to the Arduino, everything that you connect to is going to draw some amount of current. So you want to keep that in mind as um, as you like plan on, okay, what am I connecting where and where am I taking my power out of it. So then if this is not enough and you have a more demanding or complex project, there are some other alternatives. So for example, there is the Arduino Mega, which we have jumped from 14 digital input out to 54. There are 16 analog inputs, and the PWMs has also been increased. However, once again, the maximum current that you can draw out of the pins is the same 40 milliamps. So here you have a much more larger a range of pins that you can use for different applications that you might be working on. And The same power limitations apply here. Depending on what your power source is, you might have some limitation in the 5-volt and the 3.3-volt pins. Lastly, there is another model that I wanted to mention is the Arduino Duo. It's very similar to the Mega. The processor is a bit more powerful, but overall it's about the same. It also has 54 digital input outputs. It doesn't have as many analog inputs and not as many as PWMs. However, the biggest difference I will say is the current limitation. So each pin is going to be either a high current or a low current output. So some of the pins that you will need to look into the data sheet to know which one they are. I don't remember from the top of my head, but it's something you can easily find in Google. Some of them are going to be 3 milliamps, and some of them are going to be 15 milliamps. And you're not supposed to draw more than 130 milliamps total from all the pins. So that's one of the limitations with the Duo. So if what you're working on is going to be a, let's say, low power application, this might be a good option depending if you need all the input outputs. So those are things to keep in mind as you select, okay, which Arduino is the best application. Then we have a few communication protocols. You probably have most likely interact with the first one, the serial protocol. Anytime you want, usually when you want to get information out of the Arduino, you want to print your results, or you want to look at the numbers, or you want to use it for debugging. The Arduino platform comes with the serial monitor integrated into it, so you can easily monitor information that is sent through the serial protocol. And for that, you just include the line include serial.h to use the serial library. I'm not gonna go into the details of like how each of these protocol works, because I think that's something you can easily find in the internet, and it's not the purpose of this session to just go over like all the details on it, but more like show you how things work. So, and for application purposes, you will encounter different sensors or different devices that can interact with the Arduino that will need some specific protocols. And there are two protocols that is being um, designed, or they are available for this. One of them is SPI, and the other is the I2C. These two protocols have different pins out, pin layouts, and they will have different requirements, but Arduino has already built in a lot of functions that let you use them very in a very easy way. And for each of them, I have just mentioned that which library you should include in your code. And again, you can Google for examples, and they show you, oh, here's a like toy example of how to use it. And just to go back a little bit, probably this one is a better example. You can see here in the Arduino Duo, in the top right of the board, it says communication. So for example, this one has all the serial communication is here. So you have 1, 2, 3, I believe 3 or 4. Four serial communication ports. So you could communicate with serial communication with up to 4 devices based on that. There are the I2C communication pins are on the left side, and the SPI communication pins are somewhere in the middle, right next to the Arduino Duo logo. So, and probably if you're using the Uno, here's where they're going to be located. So the I2C are in the analog input in the 4 and 5, and the SPI are in the digital pins in 10 to 13. So that's where you usually go to look for them. You will look in the layout to know which pins I'm looking for. So those are the most common protocols. And once again, some devices that can interact with the Arduino, let's say you're using an SD or micro SD reader or a Bluetooth module, in most cases, they might have both protocols. Some of them might have SPI, or some of them might have only I2C. Some of them might have both. So it's something for you to look into on what protocol you should use to interact with those devices. As for sensors, I just grabbed a picture that I found. There are a very large variety of sensors available for the Arduino for measuring all sort of things, from temperature, current, infrared, ultrasonic distance. You have also push buttons. You have joystick, thumbsticks. You have humidity sensor. All the things you can imagine in photoresistors for measuring, like like if there is like how much light is coming in. All sort of things that you can imagine, you might probably find it, and usually they will come with their own board and a data sheet that's going to tell you, oh, this is how you connect and this is how you interact with the sensor. So the possibilities are large. Then we have actuators. Actuators is anything that lets you interact with your environment, and in that sense, the actuator is very limited to usually motors, like something you can move or to so probably the most common one you will find is the servo motor, especially for robotics application. You miss it. And the other one that most people will use is if the servo motor is not a good fit for your application, you might be probably looking at DC motors. Um, However, depending on what you're doing, neither of those options might be suitable. Let's say you need high torque, you need to move something that is heavy, or maybe your DC motor is too fast. You don't need it to be that fast. So that's where gear motors come in. They are a better fit for providing you with lower speed, but at the same time, higher torque. And depending on your application, for some of these, you might need a driver. So there is going to be sometimes a additional board that you will be using, such that that's going to be the one your Arduino is going to be sending information to, maybe using I2C or SPI, and that's going to be the one commanding the motor. And usually in those cases, because especially DC motors can draw a lot of current, and as I mentioned before, you cannot really provide that much current out of the pins. You will have an external power source. So this DC controller is going to be your bridge between the Arduino, which is commanding how to control the motor, and the motor itself. And again, like the power source is going to come from some other device other than the Arduino. Um, yeah. Other things to keep in mind, and they are available for Arduino that they really don't fall within the category of sensors of actuators, but I thought it was worth mentioning. You have as input devices, you have keypads, different type. You have like the one in the corner with like the flat um, keypad, or you have like the keypads with buttons, like something you might see in some devices, like I can like ATM machine or something like that. Um, then you have multiple options for output. So you have LCD displays, you have 7 segment displays, or even you have dot matrices, which can have varying sizes. All these three type of displays will have all sort of sizes. LCD, they come in 2 by 16 or I think 4 by 20, and they some of them might have even higher resolutions. 7 segments comes either in pack of 1, 2, 4, or 4, I believe. Um, and the dot matrices, I've seen like the ones that is there, that is squares, I think it's 8 by 8, but I've seen some of those like are much larger. And some of them, as you can see, might have a, well, I believe the one in the picture is connected to a microcontroller directly. Um, so yeah, so there are multiple options for you to either request information from your environment or show information to the user. Um, the last point I wanted to touch on was design consideration as you work in with the Arduino. First of all, as I mentioned before, you have different type of Arduino, and all of them will have different pin layouts. So, for example, looking at the picture I have here on the screen, you can see that, for example, this Arduino Uno is connected to a keypad and to the display. Um, Both of them require a lot of pins. So we can see, for example, the display is using 1, 2, 3, 4, four of the digital pins plus two others, so that's 6. And yeah, the others are for power or some other things. So those, so you have 6 pins dedicated exclusively for data, and then you have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 pins for the keypad, and that's pretty much all that you have available in the Arduino Uno. So if you were to use some other pins, which I believe you can set up the analog inputs as digital outputs, I'm not completely sure if you are allowed to, but if you were, then maybe okay, you can add like 6 more input outputs, but still, we are very limited because we're using a display and a keypad. So, for example, if you were to have a more complex project and you needed to interact with other things, like I don't know, like you want to interact with a motor or something else, or a sensor, well, maybe the Arduino Uno might not be the best decision. You are very limited. So in that case, you might be looking into uh, a Arduino Mega or Arduino Duo, depending on what you're doing. Um, the other thing to keep in mind is max DC current output. As I mentioned before, each pin, depending on what Arduino you're using, there is a maximum current you can draw out of the pin. So it's if you are power, especially motors. This is more relevant when you're driving motors. If you try to drive it from the Arduino, it is very likely that it won't work very well, or it won't move at all because it won't be able to draw all the current that it needs. Depending on, obviously, depending on the motor you're using. If it's a small motor that won't need much current, then you might be fine. If that's not the case, then well, that's a problem. And the last things I want to mention is the power source. Once again, depending on your application, you need to consider that, okay, if I'm connected to the computer, my power source is the USB port. USB port can draw up to 500 milliamps. Those 500 milliamps are used for powering the microcontroller. If I want to power some other devices out of the Arduino, that power is going to come from the 500 milliamps. So you start subtracting from those 500 milliamps available for each device you connect to it. So you just want to make sure, let's say, if you are powering from the computer, that all the components you have connected to the Arduino are not drawing more than, I believe, because of the current consumption from the Arduino itself, I think it can go down to about 400 milliamps or maybe less that are available for you to use for any peripherals that you connect to the device. But then if you use a power source, it's going to depend on the power source. But since the Arduino has a voltage regulator, the higher the voltage, the power source, the more is the thermal dissipation in the Arduino. So let's say you use a 12 volt or a 9 volt power source for the Arduino, which is fine because you need, I believe, between 7 and 12, if I remember correctly. So 9 volts, it should be fine. But everything in the Arduino works with 5 volts. So there is a 4 volt difference that's going to be dissipated in the Arduino. So the Arduino is going to start heating up. So there are some considerations, especially if you're going to be running this for like long periods of times, that you might be concerned about. Okay, I don't want the Arduino to overheat. I don't want the Arduino to get too warm because I'm drawing too much current out of it. So things to keep in mind. Again, this is very application specific, so this might or might not apply to your specific project. Okay. So I hope that by now everyone has been, I think everyone has been interacting with Tinkercad. The code is in the screen, but I'm still gonna share the link. You can just click on it, because that will be faster. Let me find it. Also, I'm gonna just okay, so let me, we can click it. Oh, cool. I didn't know that. Perfect. That's even better. Okay, so for the uh, logging information, I'm just going to copy. So this is just like what the Tinkercad is giving me. So just use that, and that should be good. I'm going to, okay. I will suggest for you to click in both links so you can copy the template to your account. These two are templates, and please let me know once you're done so I can show you. I can stop sharing the screen and show you my my other screen. Perfect. Harman, are you done with the? Did you copy the designs? Yeah, I'll take that as a yes. All right, let me change. I can't click. Oh, okay. Oh, that's weird. Okay, let me copy you the links in here. Here's the first one, and here's the second one. So now you can access it in the chat. Okay, let me share. Okay, which screen do I need to share? Okay, suppose that's the screen number 2. Okay. Okay, so I have shared 2 exercises. I'm gonna open the first one. I set up all the experiment, but I didn't provide you with the code. So let me show you first what I did on my end so you can have an idea. So I have set this up so that when I move the potentiometer, the motor is going to move between a number between the maximum, which is 180 degrees, and the minimum, which is 0 degrees. So that's not moving. If I put it in the middle, it's moving almost like 0 to 90. Right? So I'm going to show the code. Okay, so yes. I'm going to show you the code. This is first, if you have done anything with servo motors, you know that you have to include this library, which I think I already put in the template. You want to attach the servo to a specific pin. In this case, I connected my signal of the servo to pin 9. So that's why I say attach 9. Then I said, okay, from A0, I'm going to be reading the input from the potentiometer. So that's, I say A0, I'm going to set it as an input. And here you can put whatever you want with the code. The example I have here is you read the value, then you use this function for mapping the value that is coming from that sensor. And you say, well, this number is going to be somewhere in between 0 and 1023. And I want that number to be mapped to the range 0 to 180. No, something else. So then that's something I was initially trying. So what I did is like, okay, so my server have a couple of functions that are very useful. So for example, here we have write. So I'm gonna be writing from this value, which is an index, into the servo, and I'm gonna add a delay, so there is some like timeout. And in this case, I am running such that this number goes from 0 to the position set by my potentiometer. And then I just do the same, but I just go back. So it goes like forward and backward. And that's it. It's just a very quick example of like how you can read information from your environment, in this case, the potentiometer, to move or interact with a actuator, in this case, the servo motor. And you can control the position, and if so we saw here more or less, okay, so more or less that's the speed that is doing right now. So if I were to change the code here, if I were to decrease the delay, that should increase the speed, because now this is less delay. Or I can do the opposite. Let's say, okay, let's go with 50. So, sorry. So now the movement is much lower, and being able to control how to interact with your actuator is going to be relevant depending on the application, what you're doing. Oh, well, I think we have a question. Oh, okay. Sorry. Yeah. Well, the rest of it is gonna be recorded, so I'm gonna make sure to post the link to it after I have it. Okay. Um. So this is very like application dependent. Again, I'm controlling these from the code. Like you saw me changing this in the code. But depending on what you're gonna be doing, you might want to be able to control those from the environment. So let's say you have a potentiometer, you add a second potentiometer to control the speed, and one for the position. So now if you were to actually build this, you don't have to reprogram the Arduino every time you want to change some parameters. So now you have some physical way to control those numbers. And let's say you want to control the speed, or yeah, let's say I'm just gonna write it. I'm not gonna actually do it, but just so you give you an idea. Let's say you want to control the speed. So you can say, well, this is coming from also from a speed value that's going to be a sensor. And let's say you don't want it to be 0. You don't want to be instantaneous, but maybe you like, no, I don't know, somewhere between 10 and 50. So you can say here's going to be the speed. This is going to be the speed. Actually, since I'm already doing it, I'm just going to speed value, and this is, let's say I'm reading from A1. Let's define that, and int speed value equals 0, and int 0. So now that's the code. So let's add another potentiometer. It's not gonna be pretty, but it's gonna work. Say this is connected to A1. Let's put it somewhere in the middle. All right. That's pretty fast. See, now it's moving slower. Now it's moving even slower. So, oh, yeah. So the loop needs to finish before it adjusts the speed. So that's why there was a delay between it when I changed it to when I actually we actually saw it. So those are things you have to keep in mind. But again, this is always like application dependent. So depending on what you're doing is what you're gonna need to do. But this is a nice way to have control over your code without having to modify the code every time you want to make changes. So that's one example. So you're welcome to like play around and with that. I don't know if we have questions on that. Um, so. Okay, cool. All right. So the second one is more on the ultrasound sensor. So this is for measuring distance, and I just wanted to like have something more, a little bit more interactive. First, I'm going to show you what it does. Oh, I need to show the code for that. I'm going to do that. So it's kind of cool what they do with Tinkercad because you're able to actually interact with the sensor. So here's telling me like sensor measurement is 184 point something centimeters and 27.7-ish inches, which is pretty accurate according to what this game. So if we move it, we see the change. So if for your project or something you want to measure distance or measure distance to an object or also kind of things like that, this might be a good fit. This might be a good sensor to use for that. Obviously, this is a virtual scenario, so there are some other factors that you might consider. This is an ultrasound sensor, so it is emitting some sounds and measuring the time, the delay between when it sends the pulse to when it receives the pulse in the other sensor. So depending on what surface you're measuring, some surfaces are going to be absorbing some of the waves, and that it's something you will need to test whether this is a good sensor for your application in particular. So something to keep in mind. Now, as for the code, I'm gonna quickly go over it. This is a little more complex, and for that, I have created a function. This is overall a very good practice, especially for when you're interacting with sensors that require specific setups. For example, here we have the ultrasound that in order to measure it, first of all, you have two pins you will be interacting with, the trigger and the echo. So to request a measurement from the sensor here, first of all, you have to put the trigger pin as an output, and you have to send a low value, so 0, like a digital 0. 2 microseconds later, you put it up, so you send a 1. 10 microseconds later, you put it down. So you have sent a pulse of 2 microseconds. And 10 microseconds later, no, sorry. Yes. Sorry, the pulse is 10 microseconds long. So you put it down, and after that is when you measure. So this is a very specific setup that you need to send a pulse of a specific conditions. So it's very recommended that if this is what you need to do every time you sense a sensor, it's better if you put in a function. So in this case, I create a function read ultrasonic distance, and I give these parameters. This is where the sensor is connected to. So if you were to use this code somewhere else, and you connect it in other pins. The only thing you need to change is where it's connected. So that makes it very convenient. And what you're going to be reading is the sound travel time in microseconds. So depending on how you're using, I mean, I have included the math already here, but you can look it up. This is derived from the fact that the traveling wave travels at the speed of sound. So you base on the speed of sounds. If you know the distance, sorry, if you know the time, you can derive the distance. So if you use that equation, you come up with that the number that is returned, you need to divide it by 29 and divide it by 2. And that's going to give you the distance in centimeters. And then if you want to give the distance in inches, then you just divide the number by 2.54. So that's, depending on your application, what you need it for, that's going to be the way to do it. And then in this case, I was given the output to the serial so I can look at it. So I just was printing the measurements to the serial port, which I initialize here. I think the Arduino here is a little more permissive. So for example, here I haven't included the serial library, but still work. So don't take this as granted that, oh, this is how it works, because this is a different platform. This is not the actual platform that you use for Arduino. So, but the overall idea is that you have a function that's gonna sense your sensors. Like, depending on what you're using, some of them might be more complex. So that's when you need to look at examples or the data sheet that says, oh, you have to send this pulse of X distance and X duration to be able to retrieve data from the sensor. So this is very convenient. And from there, you can do whatever you want with that information. You can put it out to a serial monitor. You can put it out to LCD display or anything that you want to use for it. So yeah, so that's it. And well, that's pretty much all I wanted to cover today. Again, at this time in the semester, I'm guessing like most people have already done. Anyone working with Arduino at this point in the semester has already implemented one sensor or some actuator of some kind. So I hope that this is still useful. And for the next 10 or so minutes, I'll take questions since I know. Well, I also want to be able to help if you have any particular question related to your projects. All right. Well, if there are no more questions, I'm just here. Where is my? Well, if there are no more questions, well, thank you for joining today. If you have anything you want to know, just feel free to send me an email. I'm always available. All right. That's it.